we are going to create a bell curve in Excel. Bell curve, in other words, histogram we are going to create, and we are going to apply the formula called y equal to 1 divided by standard deviation square root of 2 into pi. So before I go further, I just wanted to talk about pi. You may say pi looks to be what function pi is doing it here, because it's just a bell curve. Not we're not talking about circular motion, and we're not talking about circle or oval and all that. Why that pi? Why not sine theta, cos theta, and that things? There are so much mathematical derivatives went into it. Some example like integration, differentiations, and so on. And the best fitting is pi, right? And the same thing, even if you try to apply in sine theta, another thing, so you will not get as precise as bell curve it gives with pi. So this is about pi. Let's go further. And then e the power, the exponential is a constant value that has the value of 2.71828 minus x. X is your initial value. So whatever the initial running value you have, you can apply, minus mu. Mu in this case, the average, whole the power 2 divided by 2 into standard deviation, square root of standard deviation, right? But here the fun part is that even if you, this minus has been applying it to both numerator and denominator, if you just give minus in Excel, for example, in this formula, if you just neglect this one bracket, what Excel will understand, Excel will try to do that minus only for this part, not for the whole part. So you have to be little careful with the Excel. Now we are going to do it, because if this does not come like this, you will never be able to create the bell curve. You will be able to create maybe a parabolic shape or not the bell curve shape. You are going to get it. That is very, very important. So this formula also, I will keep it in the description so that you can have a practice. And then we'll also will talk about how to apply that the x values minus 3 sigma to plus 3 sigma are in a standard deviation, and there are many methods to it. We are going to talk about it. In order to achieve the bell curve, we are going to do smooth lines, right? The formula, which the other formula which we will be using it, average, because we have the mu, so we are going to take an average, and a standard deviation p for population, but I have used standard deviation sample because my sample data and I verified in many tabs, so it looks like it is accurate with the sample. So I'm gonna use sample, and then increase that x value. So in order to have a smooth, so and then style we can do that. One, we will have a clear bell curve, clear chart, and so on and so forth, right? So when it comes to histogram, this is the three options you have in histogram, right? One option is option A, where you can directly put the value. The drawback of this option is that it will give a bucket, for example, 6.1 to 6.765, 6.65 to 6.7.2, and so on and so forth, right? It is very difficult to understand from the bin. Another one is that you can just literally take, for example, your average is 6, when your average is 10 example. So take 3 decimal before and 3 decimal after. So that is also one of the way. And then I will talk about it, but this may not be very accurate. And then option C is the right one, which applies and endorses the statistical method, how to apply -2 plus 3 sigma method. So that we are going to learn. Very easy formula I have substituted. You can definitely get this up, right? So now what I have done, so this is my example one where I have created the data. Using the data, I have created this histogram. And then, of course, I have used the bell curve assets, right? And this bell curve is a very tricky part. That's what we're going to apply. Using that formula, we're going to apply. And example number 2, where I have taken the data of 300 data set, you can see here, and my n equal to 300. And in 300, count equal to 300. So in the 300, you can find that this data I have already tested in Minitab, and it shows that the data is normally distributed. I have asked random data, but I have checked normality. Why normality is important? Variability in variable chart, normality test is important. Once the normality test is being confirmed, you can find and predict the value. And there is something called, we will talk more as we go along, we will talk about it. And we can predict it, -1 to +1, we say 68% of the data, plus -2 to +2 95, and then you have 99.73. -3 to +3. So we can predict that value also as well, right? So normality gives more prediction, more accurate, and you will be able to have the data is skewed too much, the data does not conform normality, then a bell curve also get not in a symmetrical shape. So it is not very possible and technically possible to create a very, very, very symmetrical shape, but at least we can close to that symmetrical shape as well. Okay, before I go further, what I will do, I will just create this copy. And now I will just take that simple Excel. I will just give the name called YouTube, right? So YouTube explanation example. Okay, I will just copy this value. And it has not given anything, so I have to take these values also, mean, standard deviations, and so on. I will just copy this, take it here. Now the formula should work, right? Okay, now this looks to be easy, and when you apply that formula, this is a formula we have talked about it, right? And okay, so now let's apply that formula, and I will do it in this method, and I will do without applying bracket. What happens to that, right? I'll do both, right? And maybe I will without bracket, I will apply this. So you see this is incorrect method, okay? So I'll just prove it to you why it is, I'm stressing so much on this. We can talk about it. Okay, let's go further. I'm gonna delete the entire data formula, and let's create the formula. Mean is standard deviation. Let's create that formula first. We have a standard value 2.71828, so I'm not going to disturb. So average, so this is my average. So only Excel has a one formula, so we can definitely use that up. Standard deviation has, so sample formula I will use, not the population formula. Although there is a subtle difference between these two, so I will use only S formula. So I will give this one. So I found that the standard deviation is 1, right? That's pretty high, right? So still, so we can use that up. And then now I started applying the formula. 1 divided by standard deviation. This is my D. I symbolically kept D in standard deviation, D standard deviation, C in mean, and E in E value. So D, and then times square root of 2 into standard deviation. Again, we are going to do that cap. So apply into 2 times. Okay, this part is done. I mean, the numerator, I mean, this particular section we have done. Now we are going to do the E part. In E part also is tight. So E is this one. This part is also okay. Now the next part we are going to do it is this part, right? Here we can apply, for example, this is multiply, right? So this is exponential form, sorry. In the exponential form, I will put cap, and here I have applied minus because and I have given minus here. This is the tricky part in Excel. And then again, I have given minus. So this minus I have used for this. I'm going to close it later. Okay. And then X, this is my X value. And mu, that is mean value. And then the whole power 2. Whole power 2. But I want Excel not to get confused with this. So I will just close this part, right? From this to this part, I will just do that. So this expression has been taken as this, as a product, not as this one, right? Not as this, only this one. So this part has been done. And the next part we're going to do it is that divided by 2 into standard deviation. Again, I will go to D and times 2. So now you may ask that I'm going to give one more bracket. You remember that we have open only one bracket for minus. So one more bracket I will give. So this has given this value. So let's check that up. So 1 D2, D2 our standard deviation. Okay, 1 second. Yeah. So D2 is our standard deviation square root of 2 into so pi we have missed pi actually. So square root of D2 into pi. Pi has that formula. So 2 in square root of 2 into D2 we have added. Okay, let's do that square. Okay, standard deviation is square root of 2 into pi. Oh, sorry. This is pi actually. This is pi. Sorry. Pi has the formula pi. Sorry, pi is a pi, right? So into, I think we have applied wrong formula. So let's do it again. Sorry about it. So one divided by standard deviation. This is the standard deviation, and then times the square root of 2. 2 is 2, number 2 into pi. Pi is pi, and then this is what it is. So this will close this one, right? And then the whole expression we are going to do it again. E, we are going to combine E, and then minus this part. I was saying that we can apply minus, sorry, minus here, and then x, this is x value. So again, what I will do, I will give one more bracket. So x minus, and then mu is what? The standard deviation, of course, whole the power 2. Not just applied to standard deviation, but whole the power 2, right? And I will close this up. So just to denote that this formula has been applied, and now divided by 2 into standard deviation, 2 into standard deviation. Okay, so 1 second. So again, we have not, okay, 2 into standard deviation, okay, mean value. Again, we have we have not done it actually. So x minus mean value, sorry, mean value is this. So this we got it. 2 into standard deviation is here, and then whole the power 2, whole the power 2. And I will close this, and I will have one more one, that is for minus 1, right? The black color. So this one, let's see that what we have done wrong. So standard deviation is D, and square root. Okay, I put like square root actually. I need to put square root and 2 into pi, and this is the one. Okay, something is wrong here. So e e value we have got it, and d2 standard deviation and square root of 2 into pi, 2 into pi, and then we have e value minus a2, this initial value, c2 is the mean value, this is correct, whole the power 2, and then 2 into standard deviation, this is correct. Okay, so something is wrong here. So what I will do, something wrong here. Let's apply using this one. So 1 divided by d is standard deviation for us, and square root 2 into pi, and then okay, so we are applying directly here. So and then e2 value, and e value we have multiplied with constants, and A2 is the individual value for us, and C2 is nothing but mean value for us, and whole power 2 divided by 2 into standard deviation whole power 2. So I will use this formula and I will drag this. Now we got this value. Now we can do the magic now, right? So histogram we can, and this formula is we can keep it aside. And what I was saying is that even if you apply this formula just without bracket, you will not get that bell curve, right? That's what my initial point, right? So even if you put this value and the only instead of E is fine, and okay, so instead of E, I'm gonna give it like this. So okay, so the only part which I'm going to do the trick is that I'm gonna remove that minus, and you see that the effect of this has given a different value altogether. And now even if I do that bell curve, you will not get bell curve, right? So you will not get a bell curve. So you get it something like this, you get it something like this, or like this, or like this, right? Even if I put these two value together, also I'm not gonna get that value. See, so here actually like it is okay. It is this is the original value. Even if you put this one, you are not going to get this, right? So I have just selected and I'm just giving it here. See, you are not going to get that. That's what my point. So this is just given the curvature, but not, this is incorrect method. Just I removed that bracket. So the impact of that is this one, right? So let's go one by one. First, we'll create the histogram as we said here. Histogram option A, option B, option C, and option A is a direct method, right? I will create that one, and then I will create option B, right? I will create that up, and then I will create option C. Okay, so let's do that one by one. Option one is that you we'll just discuss about the bell curve later, but we are talking about option A, direct method. You can go to recommended chart, and in the recommended or you can go to this chart, you will get the histogram, right? So it has given this is option A, right? Where you can get this histogram, everything. And then if you want to have the value, you can have the value also as well, data limit and all that. And then like if you don't need, you can just delete this value because we already have that value. We don't need to show that up. Okay, this is one value, right? This is option A for us. Okay, this is option A, and then okay, what I will do, I will just send it to front. So this is option A for us, right? So this is one, and then option B method is where you try to just give a bin. For example, we know it is going to be 10 and standard deviation is roughly 1, right? So what you can do, you can give a bin, right? A rough bin, we can call it rough bin. And 10 mean I will start with something 8, or I will start with a 7, 8, 9, and 10 is my mean, 11, 12, 13. This is something we can do. This is called rough bin, right? And then we can have the frequency. So frequency can just add that up. Let's say you want to add the frequency of this versus this, right? There is no, only one value is there, which is around 7. And then you drag that up, right? But something wrong with this. So some value should be 100, but it is showing something wrong, right? So that's the reason. Maybe my Excel is older version, so that's the reason it's giving it. What I will do, I will just make use of this version assets, right? So data analysis I will use, histogram I will use, and then input I have already taken A2 into 301, and this bin range I'm gonna select this as a bin range, right? So I will start with the 7, and I will store it somewhere here, example. give okay. I'm not interested in Pareto and all that. Just this chart will be enough for me. Or if you want, you can put the chart also, right? So it has given that something like the bill curve like this, and like this it has given. Let's say we want, let's say it has given that bell curve like this, right? So this is one of the method, right? So where you can directly get this one and all that, or you can directly, or you can manually select and get this one also as well. The one quality check which you can do is that sum should be 300, right? In the previous one it has given more than 300, I said, very more than 300. So this same thing, any one we can take it. So both looks to be same. Let's say I will take this itself as one of the method, right? So this is option B we have. I'll just keep it here, keep this one, and send to front. Keep this up and put it up here. This is option. The third method is a very formal method, right? And how to calculate this one is the bin. And first you just start with the this value, that is C. I mean that is mean value, right? So in this case C is mean value. Okay, I'll just keep it this decimal only two places, so easy. Okay, so this I have taken the mean value here. Okay, now what we can do, minus one. So this minus standard deviation, right? So this is also going to be absolute reference, so I will give a 4. This also is going to be absolute reference, I will give a 4, right? And then copy this, put it up here, minus 2, right? The only thing is I will put like 2 into standard deviation. This is 2. And I'll put 3. Right? 3 I can put here. This is great, right? So now the other bin I can do it is that copy this one, and instead of plus I will put minus, I will put like this, and instead of minus I will put plus. Then again I will do the same thing, copy, put plus. So this is the bin it has given. Maybe I will just cut and paste it in the heading. And then this is the formal way. This is the correct way, right? So let's count that how many number of times, right? Again, I'm not going to use that frequency formula. You can use it if you are using the latest edition of Excel. But let me go ahead and take this formula, histogram, and the range is same. The only thing is bin's range is different now, right? So I will just select this 7th value. So standard, I'm going to keep it here somewhere. Here I will keep it, and I will ask for the chart again. So this, just sum this up, it should be 300. So I don't need more here. I'll just place this one. So I don't need this. I'll just select this value and drag this up slightly up. So this is also one of the method, right? So you can do this method, but this is a more accurate method, right? So you can get to know how much values are there and all that, right? So let's say we don't need this, we can just close this up, and all that we can do it. So this is most accurate way, right? This is gives a bin, and this is our mean, and minus 1 plus minus 2 minus 3 sigma plus 1 plus 2 plus 3 sigma. It gives the bin like this. So anything, it has created a perfect bell curve as such. Okay, now either way you can do this, or you can also ask for this method. You can go to insert, ask for this method. I mean, in the recommended chart you can find this, right? So you can find this any one of these, both are same, pretty much same, right? So you can again you can do formatting and all that. So I will just use this as a formal one. So I will just copy this data and keep it here, and I will call it as send to front. I'll keep it here. So this is the three ways you can do that one, right? So this is what you can do. Histogram, even you can do this one. For example, let's say this also like histogram, or you can do this way, or you can do this way, right? All these way we can do, but this is very easy and formal, right? So for example, this is the mean, and then this is mean minus 1 sigma, minus 2 sigma, minus 3 sigma. Similarly, plus 1 sigma, plus 2 sigma, plus 3 sigma. Right? You can easily get to have. So whichever it suits for you, you can use it. But this is the recommended one. Now we have come to this part. The last part we are going to do it is that bell curve. Bell curve is a very important part of histogram, right? What we added was manually. You can just click here. So now we are going to do bell curve as such, right? So for bell curve, I'm going to delete this part. And so I have done that separate introduction on that. Okay, so now we'll do the bell curve. So bell curve, you can just go to insert, and recommended chart itself, it gives a bell curve to you, right? It gives a histogram, and also it gives a bell curve. Let's say we need a bell curve. And in the bell curve, right? So for example, let's say you don't need all this, and then you want this value to be starting with we know that minimum value. In this case, the minimum value is 6.91. Let's say start with the 7 example, or 6.9 will start, right? And then it has given this bell curve, very nice bell curve it has given. You can see here, right? And then we know that 10.1, and if you want to add that value, different value, we can adjust that also as well, right? So different ways we can do that bell curve also as well. And so this, since it is our data is slightly negative skewed, for example, if you look up here, slightly negative skewed, so left side dominance in the curve. Otherwise, we can use that also as well, right? And like this, you can fit this one back, this curve, you can fit it here also as well, right? So that's how also you can do it. I hope you find it very useful about the bell curve, and using this, applying this formula, you can easily calculate the bell. Please do like, share, subscribe my channel. You have a wonderful day.